The astounding truth about magnetism. Magnetism has puzzled scientists for decades. Now, at last, the way magnetism really works is revealed. All atoms have electrons whizzing around the nucleus. If the nucleus were the size of Earth, the electrons would be the size of tennis balls. Electrons are kept orbiting the atom by the immense gravity of the atom's nucleus. All electrons in atoms have elliptical orbits, however slight. As each orbit shifts slightly, it ensures electrons will, in effect, cocoon the space around the atom's nucleus. When, for example, a magnet and paperclip get close, the atoms in the magnet and the clip overlap. As a result, the orbiting electrons of the atoms also overlap. It is known that these electrons either have a spin-up or a spin-down orbiting direction around their atoms. When the combined electrons in the magnet and the clip are mostly spin-up or mostly spin-down, then you have a same-way spinning scenario. With same-way spinning, most of the combined electrons will bump into each other because of the elliptical nature of all electron orbitals. As they bump into each other, the electrons will push each other out of the way. This bumping is referred to in science as molar scattering. This makes electrons try to go in all directions, causing the magnetic repulsion force. With magnetic attraction, most of the electrons in the magnet will be spin-up, and most of the electrons in the paperclip will be spin-down, or vice versa. As the magnet and clip get close, their electrons will overlap and bump into each other. But they do so at a very high speed because they are spinning in opposite directions, going towards each other. This super high speed and momentum is so great that when they bump into each other, they only very slightly jerk each other out of the way as they pass. This is not enough to dislodge either electron from its orbital. There is no pushing away action among the electrons, so there is no ensuing repulsion force. Furthermore, atoms are much more stable when they have two paired electrons in their orbitals rather than just one unpaired electron. So when the magnet and the clip meet, the force of attraction will be strong. This is because the unpaired electrons in the magnet and in the paperclip will line up as if pairing, albeit temporarily, until the magnet and clip are separated. See the link below. What is magnetism? Which examines a big misconception in magnetism. Subscribe now to stay informed.